Namaste my dear students, Nenu mi Suryateja from Saimedha Ecet Coaching Center Koti, Hyderabad. Director JC Sir Advaryamlo, Shashikanth VALMIKI Sir Parvekshana నిర్వహిస్తున్న Saimedha Coaching Center Koti, Hyderabad. Ecet 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాశారో, ఎవరైతే క్వశ్చన్స్ కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాశారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేసింది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్. డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారు ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్ కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు ఈ డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్సు మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
Hello my dear all aspirants, let me provide the key and solutions for AP Ecet 2023 for the subject chemistry for SHIFT-02 here. So it is not physics, it's chemistry. I am going to provide the solutions for chemistry here. Right. In a hydrogen atom, if the energy of an electron in the ground state is 13.6 electron volt, then that in the second excited state is. So clearly here I am going to define here. So n is equal to 1 is ground state, actually this ground state. So ground state, this is ground state, and n is equal to 2 means here it is first excited state. N is equal to 2 means second excited state. N is equal to 3 means here, sorry, N is equal to 3, N is equal to 3 means second excited state, N is equal to 4 means third excited state, like this. So like this will be. So we need to find the energy in second excited state. So for second excited state, N is equal to how much here? 3 here. And you know, for energy of nth orbit, we have the expression energy of nth orbit is given by simply energy of nth orbit. Nth orbit or nth shell is given by simply En is equal to if you consider only magnitude, 13.6 by n square electron volts. So 13.6 by n square means 3 square. For second excited state, n is equal to 3 square. So 13.6 by 9 means how much here? 1.51 electron. You verify here, 1.51 electron volts. Where it is it? It is given option 1. Option 1 is the right answer. Which of the following sets of quantum numbers is correct for an electron present in 4f? See, for 4f, what about the principal quantum number? N must be equal to 4 here. So main shell N is equal. For F, see, we know here L values. If we consider the azimuthal quantum number values for various subshells here, for S it is 0, for P it is azimuthal quantum number value is 1, for D it is 2, and for F is 3. So 4f orbital means L must be equal to 3. And here in option 1, N is equal to 4, L is equal to 4 here, it's eliminated. And option 2, N is equal to 3, eliminated. Option 3, N is equal to 4, L is equal to 3. So, okay, in option 3 and option 4, these are matching. But here, M values, magnetic quantum number values are always lie from minus L to plus L. In that case, what about the magnetic quantum number values here? Minus 3 to plus 3, minus 3 to plus 3. But here he has mentioned here plus 4. This is not possible for 4f. This is not possible for 4f. But here clearly magnetic quantum number value minus 3, 2 plus 3 means minus 3, minus 2, minus 1, 0, 1, 2, 3 here. Yes, of course here plus 1 is possible here, plus 1 is possible, and S equal to plus half is also possible. So the possible combination of quantum numbers for 4f orbital simply N is equal to 4, L is equal to 3, M is equal to plus 1, and S is equal to plus half, right? So option 4 is the right answer. Which of the following statements in relation to the hydrogen atom is true? 3s and 3p orbitals are of lower energy than 3d orbitals. See here, actually if you consider hydrogen, so what about atomic number of hydrogen 1? So here it has only one electron, that is also in 1s. Actually in case of hydrogen, this 3s, 3p, 3d, all orbitals are empty. Actually in actual scenario, the orbital with no electron has no energy. The empty orbital has no energy, means zero energy generally in practice. So when the orbitals are occupied with electrons, then we may deal with their energies actually. So empty orbital means simply actually no almost no energy only. So in case of hydrogen, all the orbitals 3s, 3p, 3d orbitals are empty, so they contain almost same energy, which is equal to almost 0 here. So 3s, 3p and 3d orbitals all have same energy. Option 2 is the right answer. Variable valency is shown by, actually we have four types of elements here. S block, so S block elements, and P block elements, and D block elements, and F block elements. Actually D block elements are known as a transition element. They are inner transition elements. Clearly inner transition elements. S block elements do not show. S block elements generally are first group as well as second group. They will never show variable valency. Their valency are fixed. So their valency are fixed. They do not show. They do not show variable frequency. They do not show variable frequency. Variable valency, not frequency. Variable valency. They do not show variable valency. Their valency are fixed. But here the P block elements, whose atomic numbers are very high, and the transition element nothing but D block elements, and F block elements generally they do possess what? Variable frequency. In case of F block element, generally the due to incomplete filling of the F orbital, they do exhibit what? A variable valency. So excluding S block element, generally P block, there is a tendency of variable valency for P block, D block as well as the F block. So if you see the options here, a variable valency is shown by not S block elements here, S and P block. So S and S block strictly no, P and D yes, of course here yes, all elements means SPDF no, we excluded what? S block elements. So P and D block elements will show variable valency. So option 3 is the right answer. The compound in which C uses its sp3, generally it's almost here in all these given compounds here, the carbon atom in methyl group, the carbon atom in methyl group will form what here? sp3 sp3 hybrid orbitals, and in other groups means apart in CH or COH here, in other groups carbon forms, in carbon in other groups forms generally here sp2 here in CSC CH what happened here, all sp3 as well as sp2 all orbitals, all hybrid orbitals generally will participate in bond formation. Here also all sp3 as well as sp2 will participate in bond formation, and here also all sp3 and sp2 orbitals are responsible for the bond formation, but here exclusively here in here this compound only sp3 orbitals will be responsible for bond formation. sp2 orbitals are not responsible. sp2 orbitals are not responsible for bond formation. So the compound in which C uses its sp3 hybrid orbitals for bond formation means here strictly here this one here right, CH3 taken thrice CH. Option 1 is the right answer. The concentrated sulfuric acid that is sold commercially is 95% H2SO4 by weight. If the density of this commercial acid is 1.83 grams per centimeter cube, the molarity of the solution is here. See 95% H2SO4 means see commercially the commercial sulfuric acid is 95%, means 100 grams, if you consider 100 grams of H2SO4 actually contain what here? Only 95 grams. Then what about the number of moles? Number of moles of H2SO4 is given by what? Number of moles here. What is its actual weight here? 95 by actual weight of gram molecular weight of H2SO4 is 98. So 95 by 98 means 0.969 approximately. And here he has given what here? The density of the commercial acid. Density is given here. Density. So density is equal to here mass by volume. Then volume is equal to mass by density. What about the actual mass? Actual mass is 100 grams. 100 divided by divided by 8. Density is what here? 1.83. It is approximately 54.52. So it is what? 54.52 54.52 into 10 power minus 3 liters. Right? 10 power minus 3 liters. So 1.83 grams per centimeter cube. This one here. So if you simplify, the volume of the solution is 54.52 into 10 power minus 3 liters. Then what about the molarity here? Molarity is equal to number of moles are given 0.969 divided by this one 54.52 into 10 power minus 3 liters means here it is approximately equal to actually 17.8 molar which is near to what here? 18.3 here. 18.3. You check these values here. I didn't use calculator here, but I have provided approximate values here. Anyhow, option 4 you get what here rounded to here 18.3. So this is approximate value here, and you need to follow this procedure. The density of a solution prepared by dissolving 100 grams of urea, gram molar weight is given here 60 units. In 1000 grams of water is 1.15 grams per milliliter. The molarity of the solution is. So here what about here urea is solute. is clearly solute, and how the solution made, and water is solvent. Water is clearly solvent. Solvent. So let's solve this question here. Weight of solution. Weight of solute is clearly how much here? Urea, 100 grams of urea, 100 grams, and weight of solvent. Weight of solvent or weight or mass here. Weight or mass. Solvent is what? How much here? It is 1000 grams. 1000 grams. Then or weight or mass here. So simply mass. I am considering mass of so mass clearly. So what about mass of solution? Mass of solution is what here? Mass of solute plus mass of 1000 grams. So 100 plus 1000 means 1100 grams. Then what about actually density? D is equal to mass by volume. Then what about volume? Volume is equal to mass by density. So mass, how much here? Mass is 1100 grams. Here we are finding volume of the solution. Volume of solution in terms of liter. 1100 divided by density is what? Density 1100 grams divided by density clearly 1.15 grams per milliliter. Grams. So if you simplify, what will you get? You will get a volume as simply volume as 956.521 liters here. Then what about the what we need? What about the molarity? And anyhow, moles. Moles of urea. Number of moles of urea is clearly weight of the solute. What is weight of the solute here? Clearly it has given 100 grams. What about the gram molar weight of urea? 60. So it is what here? It is 5 by 3 means 1.67. Molarity is equal to number of moles of the solute divided by number of moles of solute divided by volume of the solution in terms of liters. So number of moles 1.67 divided by volume of the solution 956.521 is equal to 1.74. We'll get 1.74. So here it is given in option 4. Option 4 is the right answer. When a crystal of solute is introduced into a supersaturated solution, actually what is a supersaturated solution? Supersaturated solution means what? See, at room temperature generally every solvent can dissolve some amount, a fixed amount of solute. But if you are interested to dissolve more solute in solvent, is it possible? Of course it is possible. So if you heat up the solution, what will happen? Then it can the solvent can able to dissolve more solute. Even though you cool the solution here, the solute remain dissolved. So such a solution is known as supersaturated solution. Means by heating, if you make the solution to dissolve more solute, then such kind of solution is known as supersaturated solution. But what he has given here, when a crystal of solute is introduced, crystal of solute, a solute is there which is of the form crystal and it is introduced into supersaturated solution. Already it is supersaturated. So what will happen? Definitely the excess solute definitely will be crystallized out. Whatever the excess amount of crystal is there, that will be crystallized out here. Option 2 is the right answer. It will be remain in crystal form only. So next question, the conjugate acid. So according to Bronsted-Lowry theory, in acid and base we have a theory here, Bronsted-Lowry theory. So generally an acid donates proton, whereas base accepts proton. But he has asked what here? Conjugate acid. See, actually conjugate acid exists for what here? We find exists for base. For base we will find a base. So if it is for base, what we need to do here? If it is base, we need to add a proton here. So what is given here? S2OH minus 2 plus H plus gives what here? Simply H. So after adding H, what happened here? Minus 2 plus 1. So the charge will be reduced. So So here what happened here? HS2O8, then minus 2 charge plus 1 charge means it is minus 1. HS2O8 minus. HS2O8 minus means option 3 is the right answer. Which of the following gases on dissolution in water make the solution means here actually CO, carbon monoxide does not dissolve, does not dissolve in water, does not dissolve in water clearly. Carbon monoxide, water does not dissolve carbon monoxide. CO2, yes, carbon dioxide, see nowadays we are using soda which is nothing but here carbonated water, nothing but carbon dioxide is dissolved in water. So CO2 dissolves in water actually. CO2 dissolves in water. So by dissolving CO2 in water, what we will get here? CO2 plus H2O gives rise to, we will get what here? H2CO3 carbonic acid. So CO2 dissolves in water, right? CO2 dissolves in water. And what about SO3? SO3 also, sulfur trioxide also dissolves in water. Sulfur trioxide also dissolves in water. So sulfur trioxide plus water gives rise to sulfuric acid. Sulfuric acid, this is also aqueous solution of sulfuric acid. So H2SO4. So SO3 also dissolves in water, but PHC, phosphine. PHC means here phosphine. So phosphorus trihydrate means phosphine. It does not dissolve in water. Only CO2 and SO2, B and C options. Where are they here? So option 2. Option 2 is the right answer. On electrolyzing a solution of diluted sulfuric acid between platinum electrodes, the gas evolved at anode and the cathode are respectively. See, if you consider the electrolysis of diluted sulfuric acid, what are the chemical reactions that are going to happen at anode as well as cathode? I am writing the chemical reactions that occur at anode. At anode, what happened, you know? At anode, water splits into oxygen. Water forms oxygen and plus 4 electrons for 4H plus. So at anode, oxygen gas is going to be evolved. At cathode, what is going to happen at cathode? So at cathode, what is going to happen? Two hydrogen plus ions and 2 electrons. So 2 electrons act. So at cathode, reduction is taking place. So right, and 2 hydrogens plus 2 electrons equal to 2H. Next, or simply H2 hydrogen gas gives us to what? Hydrogen gas. So at the anode, oxygen gas. At anode, which gas is released? Oxygen gas. At the cathode, hydrogen gas. At cathode, hydrogen gas. So please here, at anode oxygen, at cathode hydrogen. So clearly mentioned option 3 here. In an electrolytic cell, flow of electrons is from cathode to anode. So here I am going to consider an electrolytic cell. So here we have two electrodes. So assume here this is positive electrode, this is negative electrode. Positive electrode is clearly anode, negative electrode is what here? Cathode. And if you provide an external source here, what happened here? The current flows clearly. The current flows from anode to cathode. Reversely, see here current flows from anode to cathode. Reversely, electron flows from cathode to anode. So where it is here? So the electrolytic flow of electrons is from cathode to anode in solution. Then what happened here? Cathode to anode through external supply. External supply. So cathode to anode, right here. Next. So electrons move from cathode to anode in solution, and cathode to anode through the external supply. So right here. So here the electrons are moving cathode to anode to the external supply. So option 2 is the right answer. The thermodynamic efficiency of a cell. See, actually the thermodynamic efficiency of the cell is generally it is represented as the ratio of Gibbs function to the ratio of change in Gibbs function to the change in enthalpy. So delta G by delta G, where G is what here? Gibbs function. So from this here, if you consider magnitude here, then NFE by delta H, where N is number of electrons transferred being reaction. How many number of electrons are transferred during reaction? N. F is Faraday's constant, and E is EMF of the cell, and delta H is a change in enthalpy. And you know the thermodynamic efficiency of the cell is defined about NFE by delta H. Where is the NFE by delta H? So clearly I mentioned number of electrons being transferred during reaction. F is Faraday's constant. E is the EMF of the cell, potential of the cell. Delta H is change in enthalpy. Then here at 25 degrees centigrade, the standard EMF of cell having reactions involving 2 electron change is found to be 0.295 volts. The equilibrium constant of the reaction is. So what is the N here? N, how many number of electrons are transferred here? N is equal to 2 here. 2. In that case, what about here? He has provided already E naught, the standard EMF of the cell. So E naught cell is given as what? Minus is given as 0.059 by N into log Kc. So it is equilibrium constant, log of Kc here. So from this, what happening? Log of Kc here, the base is 10 here, is equal to N into E naught. So EMF of the standard cell divided by 0.059 is equal to N is what? 2 into it is what? 2 into 0.295 by 0.059. So what is here? It is approximately equal to 10 here. So log Kc base 10 is equal to 10. Then what about the equilibrium constant? Kc is equal to 10 power 10. Kc is equal to 10 power 10. Where it is? It is given in option 3 here. Option 3. So to answer this question, first of all, you should know this relation here. Nernst equation. From Nernst equation, what the EMF of a standard, the standard EMF of the cell is given by 0.059 by N into log Kc, where Kc is equilibrium constant of the reaction. Then what is the chemical formula of calgon? What is calgon here? Calgon is generally used for water removal, water treatment. So calgon is used for removal of permanent hardness of the water. So generally calgon is used to remove calcium plus 2 means Ca plus 2. So calgon is used to remove Ca plus 2 and Mg plus 2 ions. So generally calgon is used to remove calcium and magnesium ions which are present in the water here, so that permanent hardness can be removed. So calgon is, the formula of calgon is NaPO3 taken 6 which is known as what? Which is known as simply sodium hexametaphosphate. So chemical name of calgon is sodium hexametaphosphate. So what about the use of calgon? It is used for water treatment, used to remove the permanent hardness of the water. So what is the formula for calgon? Sodium metaphosphate, NaPO3 taken twice, whole taken twice. Alkalinity of water is due to the presence of, see in water so many minerals are present here, so many so here actually pure water is generally neutral, but due to presence of hydroxide ions, carbonate ions, bicarbonate ions, generally what happen, water will possess what here? Alkalinity. So why the alkalinity character exists for water means here due to presence of hydroxide ions, carbonate ions as well as the bicarbonate. So all are responsible for alkalinity of the water. So where are here? All three are correct here. All three are correct. Brackish water means here actually it means that in brackish water generally the salinity is more. Salinity is more means more salts are present in the, if more salts are present in the water, then it is treated as what here, brackish water. Generally, brackish water means generally salt water. Actually, yes, salinity of brackish water is not more than that of sea water, but is less than sea water only. But salinity of the brackish water is more than fresh water. Generally, when we can get this brackish water means here, when fresh water is mixed with sea water, then we can expect what is brackish water. So brackish water means simply what here, salt water. In brackish water generally salinity is more when compared with fresh water. So it is salt water. Which of the following two metals are corrosion resistant? Generally, iron is subjected to corrosion here. Iron is subject to corrosion and molybdenum is subject to corrosion. Right, molybdenum subject to corrosion. Here, it's corrosion. But and molybdenum is subject to corrosion here. Copper does generally not subjected to corrosion here, and nickel also not subject to corrosion, not subject to corrosion here. So which pair does not generally, which pair is not subject to corrosion means here nickel as well as the copper. They are not generally, they are simply corrosion resistance. Corrosion resistance. Then the coating which protects the base metal sacrificially is. So generally what will happen, here particularly in galvanization, what we are doing in galvanization, on wrought iron, for example in wrought iron, what we are doing means here, we are laying, so we are laying the coating of the zinc here. Generally in case of sacrificial coating, what we will do means here, we will take high reactive metal, we will deposit high reactive metal over the surface of the metal is to be protected. For example, I want to protect the iron, then what I do here, I will choose a metal which is more reactive than iron and I will deposit that high reactive metal over the surface of the iron. Then here metal to be protected. So metal to be protected. For example, here I am going to protect iron here and I am laying zinc. So zinc is more reactive than what? Iron. So what happened here? So here iron will act as what? Your cathode, and it does not corrode them. It does not corrode. Here whatever the layer you are using on the iron means here this coated metal will act as, coated metal is generally highly reactive, it acts as what here now anode and it will corrode. See, zinc will corrode, but by corroding itself, zinc is trying to protect what? Iron. That's why it is known as sacrificial anode coating. Why? Because the metal which is sacrificing itself, it is acting as anode. So it corrodes. Right, sacrificial anode coating. Option 2 is the right answer. Which of the following is also known as elastomer? Elastomers. What is meant by elastomer? Elastomer is a synthetic polymer or synthetic rubber which has got the property of elasticity. Otherwise, how can we define these elastomers? Means the polymers which are capable of regaining their original shape, original structure, even though they are stretched. See, what is meant by elasticity? For example, if you stress any body here, we can expect some change in its shape. But once you relax the force, if the body is gaining its original shape or size, means the property is known as elasticity. If the body is completely changing its shape, body is failing to gain its original shape, means then it will possess the property of plasticity. And here we are talking about elastomer. Elastomer is a polymer, so which gains its original shape once the stress is relaxed, once the stress is removed. So elastomers are generally synthetic polymers or synthetic rubbers. So option 3 is the right answer. Which of the following is an inorganic polymer? Silicone, silpolyoxane. Silicone means here silpolyoxane. What is the significance of silicone means here? Simply, it is actually inorganic polymer. Organic polymer means the main elements are carbon as well as hydrogen along with the other element. So, but here in silpolyoxane, if you see the structure here, R2SiO SiR2. Here where R is what here? Alkyl chain. Alkyl chain. Right? Alkyl chain. So this is what here? Inorganic polymer. Inorganic but silicon. Silicon. Not silicon. Silicone. It is still polyoxane. Right? Then the termination step in the cationic polymerization is caused by, generally the cationic polymerization starts when cation transfers its ion to monomer. Similarly, the cationic polymerization can be terminated by reverse the anion. Simply it is anion. The cationic polymerization starts when cation transfers its ion to monomer. At the same time, it is terminated. Termination step is caused by anion only. Right? The sulfur compounds from gasoline are removed by here. So the sulfur compounds from gasoline are removed by treating with an alkaline solution, an alkaline solution which is known as a sodium plumbite. Sodium plumbite. So whose formula is Na2PbO2. Sodium plumbites. So generally the sulfur compounds from gasoline, how can we remove sulfur compounds, sulfur impurities in practice means here the sulfur compounds or impurities can be removed from gasoline by treating the gasoline with an alkaline solution which is nothing but sodium plumbite. Sodium plumbite. Option 4 is the right answer. Fluoride pollution mainly affects, see here, see in our state Telangana also here, particularly in Nalgonda in some areas we have the problem of fluorosis in water. Fluorides are present. See this fluoride, the presence of fluorides in water causes fluorosis, means which damages, which creates problems of teeth, bones and neurological problems, and it disturbs the tooth enamel. So actually fluoride mainly affects what your teeth here. It's not it does not affect the heart, kidneys, liver. Generally due to fluorides, teeth as well as what your bones, and it creates even neurological problems. So mainly affects what here calcium related means teeth as well as the bones. So bones. It disturbs the enamel of teeth. Right. Next, silicosis is caused by. Silicosis is a long-term lung disease. Silicosis means what? It is a long-term lung disease caused by inhaling larger quantities of the silicon dust, crystalline silicon dust. Right. Actually, this silica is generally present in some form of soil, rock, sand. Right. Even in air also. See, if we consider aerosols means your suspended particles or droplets. In that silica dust might be present. So if we inhale that silica dust, what happen here? We may get what? There may be a chance of getting silicosis. So silicosis is caused by inhaling. Inhalation of what here? Aerosols. Aerosols means what here? The suspended particles are droplets in which silica dust is present in air. So option 2 is the right answer.